Thank you very much. I hope you can hear me. My internet is sometimes a little bit slow out here, so hopefully this works. I'm just going to take a couple of minutes to just introduce what the RISC-V international security activities are. So my name is Helena Handschuh. I have the pleasure of chairing the security committee, and my co-chair, Joe Kinnery, is on as well, I believe. So a couple of words about RISC-V International. I'm trying to move my slides forward. That doesn't seem to work. Okay, never mind. We have, a lot of members. We have more than 12 premier members, 150 company style members, and over 1,000 individual members, and so on. It's a huge organization already. And what the organization does, it does actually own and standardize the privileged and unprivileged specifications, ISA specifications, but it also creates extensions. And so part of that is trying to create security extensions that will be useful for all sorts of security related activities that some of our members could try to and would like to have. So we have two task groups that are related to security in the RISC-V international organization. The first one is the crypto task group that is being run by Richard Newell and Derek Atkins. And the second one is the trusted execution environment task group that's being chaired by Nick Kosifidis and Paul Koo. And then we have two other groups that are special interest groups. One of them is the security response team that takes care of receiving security bugs, if any, and then trying to solve them. And the newly created blockchain SIG. And you will be hearing from all of these along this morning session. The first 15 minutes of this session will be a video presentation where all of the different groups give a little update, including one on crypto Scalar extensions from Ben Marshall, one from Simon on architectural tests for crypto, one presentation from Markku about certification aspects, how you can we can help you get certified more easily with these extensions, one from the blockchain SIG and one from the security response team. And then afterwards, there will be more presentations around security. Obviously, in this forum, there's a lot about TEE, and so we have one presentation from the TE task group later on as well. With that, I don't want to take too much extra time. There's a bunch of chats. I can't do everything at the same time, but I will look at it later. So thank you very much for joining us today. And I will give the floor back to the organizers so that they can play our little video from all the different groups.
Hi, my name's Ben. I'm going to give you an overview of the RISC-V Scalar cryptography extension, giving you just enough information to get you excited, and then telling you where to go to find out more about it. So in terms of why we're doing Scalar cryptography, well, RISC-V caters to everyone, from the deeply embedded cores all the way up to application and server class. And you need a cryptography extension that does the same thing to scale across all those points, because everyone needs cryptography, everything needs cryptography. And historically, if you wanted to add cryptography acceleration to a core, you reused the big existing SIMD or vector registers. And that's great, RISC-V will have that functionality, but that's not so good for a large portion of sort of IoT class devices. So by adding sort of small, lightweight instructions, we can get an enormous performance, security, code size, energy efficiency boost that just isn't there for other ISAs, and lets you really specialize your cores for the application that you need them to do. So RISC-V is sort of leading the way in this, and it's a bit of a differentiator for us. So in terms of what the extension actually includes, so we've made sure to keep the extension as general purpose as possible. We're reusing some instructions from the bitmanip extension, and these are general purpose, useful for many sort of cryptographic applications and primitives, things like rotations, permutations, doing secret independent lookups in memory, or doing bit bashing and careless multiply for things like GCM mode. And these keep the extension general and applicable to all sorts of cryptographic primitives. We've also got some specialist instructions for very, very critical algorithms that are very widely deployed. So these give you an enormous performance gain with as minimal implementation cost as we could define. So these are for AES, SHA-2, SM3, and SM4. So these are very sort of core ciphers in things like the TLS 1.3 standard. We also define an entropy source. So this is where you generate your cryptographic secrets for creating keys. And this is, I'm not going to go into too much detail on this one because this is the subject of another talk, but suffice to say it's been designed to be scalable, again, across microcontrollers all the way to servers, and has been defined with certifications in mind. In terms of what the extension buys you, in terms of software speed-ups, everything is at least twice as fast for things like the hash functions that we've targeted, and then for AES, in particular, you get up to 10 times faster on RV64 for sort of a very small implementation cost. It's like really, really good. We know these instructions work very well. And in terms of the hardware cost, we've got per instruction breakdowns available on our GitHub, which I hope you've noticed the link. And the dedicated cryptography instructions work out to be about the cost of the Rocket Core multiplier, as becoming a sort of unofficial standard unit of measure for judging the cost of implementations. So hopefully that's been enough to get you excited about the forthcoming cryptography extension. In terms of where you can find out more, we've got all our specifications, experimental tool chains, simulators, and sort of guides to get going on our GitHub page there. We also have a weekly updated status page on the official RISC-V wiki, and that just contains sort of standardization progress for all the major components. In terms of the ratification timeline, the specification is currently stable, which means it's worth your while starting to go and look at it and starting to implement it in your core, and we really want your feedback on this. We're expecting to freeze and go to public review imminently, and then ratification will be at the RISC-V Summit in December this year. So we're really looking forward to announcing that. Thank you very much for listening.
Hello, my name is Simon Davidmann from Imperius, and I'm going to talk about the architectural validation test for the K-crypto Scalar extension. So architectural tests help ensure that the implementer of a design understands and has implemented the specification correctly. And we have to have this set of test suites to be available before any RISC-V ISA can be released or ratified, and any product that wants to use the RISC-V branding is required to pass these tests. And they test simple things like operand usage and values, but they're not a complete full DV. And in Imperius, we've developed these test suites. We've developed many test suites for all the different ISAs, and we've donated the K as part of the Apache 2.0 as the source. And if you go to the GitHub, what you'll see is a variety of different directories if you clone the architectural tests. I'm going to talk about two: test suites and also the targets. And in terms of the targets, you need to define a target for your device. And from an Imperius point of view, we've got two. We've got two different simulators: a regular free simulator and then an enhanced one, which can be used for verification. And you'll need to create a few different scripts and header files and to be included, which basically define things about your device. And then you've got the tests themselves. If we look at the tests, there's a variety of things in here. From an Imperius point of view, we provide information about how big the tests are in terms of the data that they use and the signatures, and how many times each instruction is actually used within it. But the two interesting directories are the source and the references. So the source is where basically the assembler code is, and it's done using macros. You choose the instruction, you say what operands you want and what values. And then when that runs through the simulator, what you get out is some reference output, a signature output, which you will then compare against the reference that we will download from here. So what I'm going to do is just show you that running. So here we've got a command, a make file, so it's done with make and scripts. We're using our simulator, we're running the K, it's compiling and executing all the different tests here, and it's actually gone through and verified and compared them to the signature. And if we look in the log file for these, we can see that actually it used the user version 2.3, privilege 1.11, and crypto version 0.8.1. It ran through, and we can see we've got the signature out from it. So that really was meant to be a quick walkthrough, an example of the tests, just to show you them running there. And they're available from the GitHub now to use, which is great. And actually, I just showed you using them with our reference simulator, which actually implements all of the different ISA subsets that are available at the moment. Thank you.
Hey, I'm Markku-Juhani Saarinen from PQ Shield, and this is a quick update on the security certification status of the RISC-V crypto extension. So those of us who are working commercial crypto and information security know that with FIPS 140-3, which is the latest version, it's almost like no FIPS, no sales. And in government, it also is the case that they can't really buy your products unless you can show them some kind of FIPS certification for these algorithms. Fortunately, level 1 is fairly easy to obtain. It's based on test vectors. It's a little bit higher than our architectural testing. So you would need to have like actual algorithm implementations, but it just tests that, let's say AES is AES. A accredited testing lab will give you a quote on how much this costs, and that will help you in the marketplace to sell your products. So RISC-V is an open source organization. We don't provide cryptographic security testing, even though we provide architectural testing for the instructions, or well, tools for that. So the final outcome, basically after a year, would be this OpenSSL FIPS provider cryptographic module. So this is a little part of OpenSSL, like a mode that contains the low-level implementations of the FIPS algorithms and allows you to pass the certification fairly easily. So much of the work is kind of shared. These are little breadcrumbs that we leave along the way so that the community can get their devices certified easily. Another part is the kernel driver. The entropy source or the random number interface is only available through the kernel on like Linux-like systems. So hopefully this kernel patch will, together with the entropy source, will allow you to pass the RPG2 requirements. So while architectural testing is typically sufficient for the deterministic instructions, of course, the entropy source it's by definition, it's non-deterministic, so it can't be really tested like that. I would suggest that vendors actually attend these workshops. So NIST is shortly actually organizing the very first entropy source workshop for the new requirements, and it's $25 virtual. I would just suggest that vendors would attend this, even though it's kind of meant for the testing labs. So this will help you basically choose the appropriate IP blocks that implement the interface. We also kindly ask you not to implement the interface unless you know that you meet these requirements, because that will kind of break the trust on your chip if you're providing a service to an application that you don't have. So you're kind of breaking the ISA contract in that sense. So I guess that's it for a very quick update on the FIPS status.
Welcome to the Security Response Team Introduction. I am Don A. Bailey, the Security Response Team Chair and 18-year veteran of the cybersecurity industry. The Security Response Team, or SRT, was designed to ensure that RISC-V is the most security-resilient CPU architecture available to the public. We will build relationships with researchers, both internal and external, to the RISC-V ecosystem, bridging the gap between third-party researchers, RISC-V's implementers, and architects, so that all parties can work effectively and efficiently toward a stronger CPU specification. We'll achieve our goals by teaming up with industry leaders in the cybersecurity space, such as HackerOne, that specialize in bug acquisition and coordination. We'll create a smooth and transparent process for acquiring, processing, coordinating, remediating, and releasing vulnerabilities to both technology implementers and the general public. We'll ensure that each bug is evaluated to determine how we can best reduce the potential for new bug classes in subsequent versions of the RISC-V architecture. And we'll identify how bugs and bug classes can be applied to other architectures to give back to the global engineering community. By creating simple, transparent, and flexible processes with partners like HackerOne, we can ease the challenges researchers face when submitting findings to normally cumbersome ecosystems like CPU architectures. By evaluating each bug individually, we can create an appropriate process, timeline, and strategy for addressing each bug, giving all parties the ability to act appropriately while incentivizing a fast remediation process. Though the RISC-V architecture incorporates security by design and from its inception, there will always be challenges faced as we launch newer designs and as the architecture gains features and capabilities over time. Incentivizing researchers to work with us by creating a smooth and transparent process will grow our ability to collaborate not only internally, but with a growing global community of researchers. And heck, they're glowing too, right? Community breeds longevity, and the security response team's primary role is to ensure the longevity of RISC-V by creating an environment where everyone feels welcome to participate in the improvement of our technology. Currently, the team is led by Helena Handschuh, the security chair, vice chaired by Alastair Francis, a brilliant security analyst and current engineer at Western Digital, and myself, Don A. Bailey, a veteran of cybersecurity research and the current SRT chair. We look forward to serving you, the RISC-V community, by solving security through community. Thank you very much.
Hello everyone, I'm Patty from OneSound Blockchain, chair of the newly formed Blockchain Special Interest Group.
Hello everyone, this is Gary from Ados.io. I'm the vice chair of the blockchain team.
The Blockchain Special Interest Group was formed in February. This group will help to integrate RISC-V solutions with blockchain network. Compared to traditional centralized systems, blockchain combined with RISC-V can provide a more reliable and secure data network. The goals of the group are to ensure there are no gaps in RISC-V instruction set and make sure it meets industry requirements in performance and security. We also plan to do POC projects with chips, IoT devices, software partners. We'll also promote RISC-V to be adopted in blockchain infrastructure.
So when we talk about RISC-V plus blockchain, let's keep in mind that blockchain is an application that heavily relies on security. So RISC-V's openness could help the industry to find a better balance between the cost, the performance, the power consumption, and the security. So we have several possible interesting points. For example, the first is TEE and the root of trust. The on-chain data is trustworthy only if the data can be proven genuine from where it was captured or generated. So TEE and the root of trust could help that. And the second one is the acceleration of the cryptography algorithm, because most IoT devices are power and cost constrained. So hardware acceleration could help much. And the third point is the acceleration of the blockchain smart contract virtual machine. If a device works as a blockchain node, it will execute smart contract in its virtual machine. So if the hardware instruction could support some of the bytecode, it will help performance of the virtual machine.
And at last, welcome to join our special interest group. Let's integrate the RISC-V's valuable features like cryptographic algorithm-friendly and openness into blockchain system. Look forward to the exciting collaboration between blockchain and RISC-V. Thank you.
Thank you.
All right, I think we are at the end of our little recording. Hopefully you've had a good overview of what the different groups, task groups, and special interest groups are working on. There's one more task group that hasn't presented yet, but there will be a somewhat longer presentation from the TE task group on the IOPMP topic a bit later on. With that, I would like to thank all of the speakers that have recorded the presentations for their inputs and everything. You can send in questions. Some of the speakers are online to answer your questions. If we can't answer them now, we will get back to you at some point later on. Thank you very much. And yeah, back to you, Kim.